Bismillahirrahmanirrahim. Assalamualaikum and very good day to you all. In this video, I'm going to talk about chapter 3.2 in the Shigley Mechanical Engineering Design textbook. Chapter 3.2 is talk about shear force and bending moments in beam. Okay. 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 From the chapter 3, load and stress analysis. Okay. So this is what we are going to talk about. Uh, the shear, the shear and bending moment on the beam. Okay, the figures is taken from the textbook. You should have the textbook with you. I hope this video give some extra knowledge for you lah. Okay, shear force and bending moment. Okay, shear force and bending moment in beam analysis. Shear force V is the symbol is the letter V, and the bending moment M are critical internal responses in beam. They develop where external loads are applied. Okay. uh, it involves equilibrium of forces and moment. A cut beam section shows the internal shear force and moment ensure equilibrium of isolated section. For example, simply supported beam. For a beam with two force V and M at any section can be computed using equilibrium principle. Okay, this is the picture I'm going to talk about. Just imagine you put whatever beam, whatever wooden plank or whatever lah you put, and then you supported by the two force left and right, uh the extreme end and the extreme left and extreme right. Okay, this is the we call simply supported beam. Okay. uh okay, then you have this bending moment. The shear force is the F. Okay, is the shear force is this is the figure 3.3, the shear force. Okay, so positive shear and negative shear. You can see the bending moment whenever the force is given, it with opposing forces lah, from one up and one down. So we give the shear force. Okay. Mathematical relationship, shear force is derivative of bending moment, and with respect to distance, V equals to dm over dx. Okay. Distributed load, the rate of change of shear force is equal to the distributed load intensity, dv per dx equals to qx. Okay. Distributed load, and for example, uniformly distributed load, shear force varies linearly, while bending moment forms a parabolic curve under a uniform load. This is the picture that I'm going to about the parabolic curve, like presented by figure 3.4 here, and there is another figure is in the textbook. Okay, you can see the figure. It will form the parabolic curve. Okay, the maximum parabolic curve is the force that may applied. Okay, let's say you put a force, you apply the force at the middle of it, then the bending moment will be highest at the middle of it lah. The place that you put the force. Again, and then it dissipates. It become gradually dissipate for to the left and to the right of it. Okay. So change relationship between load and shear force and bending moment. Change in shear force. The change in shear force between two force in a beam equals the area under the load curve, dV minus dVA, equals to integration of qx dx. Okay. Change in moment. The change in moment between two points equals the area under shear force, mb minus ma, equals to integration of b dx. Example, bearing distributed load. In the beam of bearing load, the shear and moment changes can be calculated with using this relationship. Okay. And then practical example, bending in simply supported beam. Okay, simply supported beam with contracted load. The shear force diagram shows constant values on either side of the load, and the bending moment peaks at the center. Okay. This is the picture that I'm going to talk about. We are going to talk about the force is the maximum at the center, where the force is applied of it. Okay. Shear and moment values at intervals. Shear force and moments can be different section can be calculated to illustrate diagram development. For example, 10-meter beam with 5 kilonewton center load for a 10-meter long beam and 5 kilonewton load calculated shear force moment at 2 millimeter, 2 meter the interval. Okay, this is the example, and then um, you should consult your respective lecturers lah for this, okay? Because from this chapter 3 there are calculation, and my video I just explain the theory and concept of it lah. Okay. So we see you in the next video, inshallah. Thank you very much.